Parallel class is part of System.Threading.Task namespace, and it provides methods for performing loops in parallel. There are four main methods which are supported by the parallel class, and those are for.each, for.eachAsync, and invoke. For and for.each are the two which are very popularly used. For.eachAsync is very useful when dealing with asynchronous method. And the last one, which is invoke, can be very interesting and useful in a lot of scenarios. So first let's start with for. The for is pretty straightforward. We start with Parallel.For, and then it starts with an index which is inclusive, meaning if we start with 0, it will start from 0 and go from there, and to what number we want to go. So let's say we want to go from 0 to 10, and then we can provide an action, and the parameter to the action is the index of the loop. So we can say here count, and at this point we can do whatever logic we want to implement with the item in the loop. So for us, we'll just go ahead and do a console.WriteLine. And if I run this, unlike a normal for loop where it's going to print from 0 to 10 in an order, here, given that we are running them in parallel, it will print things in an unordered manner. So if I run this application now, and you can see here it starts with 0, then prints 3, 1, 2, then 4, 5, 6, 7, 8, 9. These are in sequence, but rest of them are haphazard. It's because they are running in parallel. Now the for has few overload, and one of the overload takes a parameter called ParallelOption, and ParallelOption is a class that we can use to set some of the option of how the loop should run in parallel. So for example, if we create a new instance of ParallelOptions, the attribute that we can set inside of these are max degree of parallelism. And the max degree of parallelism is the number of concurrent tasks that can run at the same time. And we can set it as -1 for unlimited, which is also the default value. If we set it as 1, it will be sequential, or we can set to some other number based on the requirement. But for our example, we'll just keep it at this. The next one is for each. So for each, we can first declare an array. So we have array of string here. And now what we can do is, if we want to do some operation on this array in parallel, we can do a Parallel.ForEach. And for Parallel.ForEach, first we can pass the IEnumerable, which is the source. In our case, it's items. And then it takes an action for which the parameter is the value, the individual value of the array as it iterates through. So we can say item, and for our case, we can just do console.WriteLine of item. And if I run this, we are going to see similar behavior as before, in terms of they will print out of order because they're all running in parallel, and you can see it right here. Now here, for example, let's say this class here, we have a function. It's an async function, and it is a function which returns a string, and let's say the function name is getName. And what we are going to do here is we're going to return await And we can use task.FromResult to create a task. And then here we can say name class, and let's add a random number to it. So for that we can use random dot shared dot next, and we can just have random number between 1 to 10. Now here what we can do is we can try to, and let's say this takes string name, and here we can, instead of hard coded, we can just have name coming in. So at this point here, let's say we want to call get name. We have to provide an await because it's an async function, and let's rename this as async to keep proper naming convention. Now we cannot just put an await here, we have to put an async at this point. And then we can do here console dot write line and try to print the item which is returned by get name. We can use here parallel async, and when we use parallel async, the lambda function takes two parameters, a string or the type of the enumerable and a cancellation token. So here instead of item we need to have item and the token. So the advantage of this is, of course, we can use this token to cancel the task at any point in time inside of the loop if we choose to. So let's run this again. And this time, as you can see, it's not printing anything because the for each async itself is an asynchronous method and it is returning a task. So we will need to await this for each async method. And now if we run, we can see it is printing out the numbers. The next and the last method that the parallel class provides is invoke. And invoke is a very interesting and can be a very handy method. So how does the invoke work? So invoke is something we can use for executing multiple lambda function part of the same invoke. As you can see, the parameters for invoke is nothing but a params of action array. And the second overload is, of course, the parallel options, which we have seen before, where we can specify how many degrees of parallelism should be used. And now here what we can do is we can start with, let's say this is one, and similarly we can have another one with the same, then third one, and then fourth one. So let's say we have four functions which we are going to invoke in parallel. Now here I'm just doing console.writeLine, but it can be any logic that we want to call. And if we run this, we can see that it is printing out those four statements. And of course they are out of order because they're running in parallel. And this is a method I think it's very handy, especially in occasions where we want to run multiple methods in parallel. Instead of creating multiple tasks, we can just use Parallel.Invoke. So that is all I wanted to cover for today's video. If you like this video, please give it a thumbs up. And if you are new to this channel and you think you are getting value out of this channel, please subscribe to the channel. And thanks so much for watching this video.